All right. Now this is full-fledged. This is going to have an X expression. It's going to have a Y expression. It's going to have a torque expression. So the first thing I want to do is let's identify all the forces acting on this thing, right? Presumably we've got a force here. Okay, a force of the wall in the Y direction. I'm just going to call that Y. Okay, then we also have a force acting this way. Right? And that is the wall in the X direction, right? And then we have the tension here. Okay. And that has two components. If that's T, it's got a component this way. Okay. And then it's got like that, right? And this side here is going to be T. If this angle here, what is that? 32 degrees, right? That's T sine 32. And then this side here is T cos 32, right? So we've got all these little components, right? The side opposite is sine, the side adjacent is cos, right? Then we've got the weight of the beam itself, right? Right, and so what's the mass? The beam is, do we know the beam? The uniform beam, it has a mass of 21 kilograms, right? So this force is 21 times 9.8. That's what G is, 9.8, right? At, let's see, where is it? It is, the beam is 5 meters long. So that's going to be, if it's uniform, the center of gravity is at 2.5, half of 5, right? Okay, then we've got the, this force here. Right, so how much is the sine? Sine is 14, right? So this force here is going to be 14 times gravity times 9.81 at where? How far does it say? Connected, the cable form. So 3.1 from the left side. So it's at 3.1. Right? And then this guy is attached 0.9 from the right end. Oh, this is complicated. Does that mean it's 4.1? Yeah, 0.9 from the right end. Okay. So this one here, this T, is at 5 minus 0.9. So it's at 4.1 from the left side, right? We always want to get, when we pick a torque point, which I've already picked, right? Okay, we always want to get these distances from the left side, okay? So again, we've got the beam down at 2.5 meters. This weight of the sine, 14 times 9.81 at 3.1, and then whatever the tension is at whatever, right? And that's at an angle of 32 degrees, okay? So let's set up our torque expression, right? The torque is, well, 0 times whatever the wall is exerting, right? Plus 2.5 meters, right? So the beam itself, 2.5 times 21 times 9.81. Okay, plus this guy is at 3.1. 3.1 times 14, 9.81. So that's the weight of this sine is torquing clockwise. These are all clockwise torques, clockwise torque, right? And then the tension, right? So that's at 4.1, so minus 4.1 times T sine of 32, right? So remember, torque is RF sine theta. In this case, theta is not 90 degrees, so we got to put an angle in there. Make sure you are in degrees, not radians. Okay, so let's see. Clockwise torque, anti-clockwise torque adds to 0. So this thing is actually solvable, right? The other expression we've got is in the x direction, right? We've got whatever the wall is exerting in the x direction, and then this component here of the tension. So T cos 32, 0, we know what theta is, right? And then y in the y direction, we've got the wall in the y direction. We've got minus 21 times 9.81 minus 14 times 9.81. So these are the weights, these are these forces, right? This guy's up, this is down, and then this component right here is up, right? T psi 30. And that equals 0, right? Okay. So we got force up, unknown force up. This is up, this is up, this is up. Now this, as soon as we get T from this equation, this will be easily solvable, right? Each one of these things, right? Okay, so let's solve this guy, right? Let's try the red pen, right? Okay, so solving this guy, I'm going to do these terms, divide by 4.1, divide by sine of 32. Okay, 2.5 times 21 times 9.8. 1 plus 3.1 times 14 times 9.81 divided by 4.1 divided by sine of 32. 433.006. So I'm going to store that in T just for fun. Okay, so T is equal to 433.006 newtons, right? So now we can plug it in there, right? Plug in 433.006 newtons, right? So I just go times cos 32, and I got 367.2. So this guy is, okay, the fact that it's positive means that it's to the right. Okay. And now let's just plug it into here. We're going to plug in 433.006. So basically I'm going to do all of this, subtract that. That'll be this one. Okay, so 21 times 9.8 plus 14 times 9.8. And then I'm going to take away this guy. And I get 113.89. Newtons. Ta-da. All right, there's that. Okay. It always will be, in all of these ones that we're going to do, it always is that if we pick a spot where the hinge is, right, this thing falls out of the expression, right, and then it becomes solvable. We should have an equation, right, and an unknown, but we just have one equation, one unknown. This one becomes solvable. Then you plug it in here, you plug it in here. There it is. I do want to see your expressions of equilibrium. Okay. If you just get the expression of equilibrium and you can't do the math, that's still worth something. Okay. All right. Happy hunting.